Now, the research on this part of learning about knowledge organization, knowledge structures, has interesting takeaway points. This is the good part. When we are able to give students a structure, in this case a hierarchical structure, this will aid retention and recall. In this particular study, where students were given lists of minerals to memorize, two groups of students were given, one group was given the structure from minerals to metals and stones and subcategories evolving from there, and the other group was just given a random list of minerals. And then they were tested on their recall. The group that was given the structure, the hierarchical structure, did way better than the other group. The average number of items recalled was more than 3 times higher than the average number recalled by students in the random list group. So that's the part where we know that there's value to this, to helping students not just memorize things, but add some organization to that memorization as they go. The bad part of this research was that experts also wanted to figure out the kinds of structures that would be there in the brain without any kind of help. And so to do that, they went into a physics course at the end of the semester, intro physics, and gave the students a stack of problems that they had to sort into groups of problems that were similar to each other. They were not interested in the solutions, just in looking at the kinds of piles the students would make, hoping that the organization on the table would reveal the organization in their brain. And what they found was that students had a lot of heterogeneity in how they did their sorting. Many groupings did not look similar to other students' groupings, but they did find patterns also. In particular, they found those 2 problems on the left for which you see the free body diagrams, but not the text. They found that those problems were often put together. And when they asked students to explain why those 2 went together, students talked about, well, it's problems about inclined planes. There's objects moving on planes at an angle. Those were the kinds of explanations given. Then they gave the same stack of problems to the experts and asked them to do the same task. And what they found there was that the experts had much less variability in terms of how they did the task. And in particular, they never put together that inclined plane problem with the other one. Instead, it went with a pulley problem. And when they had to explain why, they talked about conservation of energy as being the underlying principle behind both problems. Now, experts obviously can see that the 2 problems on the left look similar in that the free body diagram looks similar. Because it involves inclined planes and angles. But they did not think that that was a significant feature of the problem that warranted putting those problems together. Because noting that those 2 problems are similar doesn't tell you anything about how to solve the problem. And in fact, some students might have a misconception that all inclined problems are solved in the same way, which would be very counterproductive. Instead, experts know that once they've realized that it's conservation of energy, just apply the formula for conservation of energy and you're already halfway or most of the way to the solution. So the takeaway from this research is that students left to their own devices will form organizations in their head, but those organizations are not going to be helpful necessarily, and they might actually hinder further learning. Now, this is not something that just students do. I'm going to give you an example. This is the ugly out of this research to show that we are all prone to this idea in terms of forming bad organizations. I'm going to read a paragraph to you from a book. The man was worried. His car came to a halt and he was all alone. It was extremely dark and cold. The man took off his overcoat, rolled down the window, and got out of his car as quickly as possible. Then he used all his strength to move as fast as he could. He was relieved when he finally saw the lights of the city, even though they were far away. Let's think about the text that I just read. Here are some questions for you. Can you estimate the time of the day this event took place? This could be a fairly easy question. It says it was dark, so it's probably in the evening. Estimate the month of the year this event took place. An overcoat was mentioned, so it's probably one of the winter months. But then the questions become more difficult to think about. Describe the location where the car probably came to a halt. Also, why do you think the man rolled down the window? And why do you think the man removed his overcoat? It's hard to come up with an explanation for why that happened, even though everything that I've read about that event is true. The thing that I haven't mentioned yet is the title. So the title of that paragraph is The Submerged Car. Now it all makes sense. Now you understand why the man had to roll down the window instead of opening the door, and why he had to take off his overcoat in order to be able to swim more freely, and why he was so worried and why he was relieved to see the lights of the city even though they were far away, because it meant he made it to the surface. The idea here is that there is a key element that's missing that forces us to not be able to organize the events in the story in the way they're meant to be organized. If we had to picture an organization for this story, it would probably be a hub and spoke kind of model, with the submerged car being the hub on which every other element of the story hangs upon. If you remove that, I'm left with all disconnected elements. And that's why it's hard to recall. That's why it's hard to make sense of the event. That's why it's hard to draw inferences. And in fact, I would be forced to organize it in whatever other ways make sense to me. And maybe I forgot about the overcoat because the model that I superimpose on this story didn't take that into account. And then I get to the day of the exam and there's a question about the overcoat. And now I feel cheated. And it's only because I didn't have the right organization for this. So providing context to the students, even with just 3 words in this case, can help comprehension and learning a great deal. In terms of practices, what can we actually do to provide that kind of overarching organization? At the course level, some people advocate providing students with a graphic syllabus that is not just a list of topics you're going to cover in the course, but it actually shows the organization of those topics. So in this case, this is my personal graphic syllabus for a graduate course in Bayesian statistics that I taught a few semesters back. And it shows on top that there is a progression in the topics, in the big chunks of topics that we traverse in the semester. But then we drill down deeper and deeper as we go into the semester in each one of them, and how they're connected to each other and how they branch off, what the hierarchy of that is. In this particular case, I'm also providing students with danger signs to show things that will take longer than they might anticipate, or things that are counterintuitive. You think this is going to be a certain way, it's actually going to be the opposite. And so those can be good signposts for navigating the course.